Hello and welcome. My name is Dallas Stowe Faircloth, and today's topic is systems thinking of a wristwatch. Today, I will be giving a brief history of the wristwatch, explain why it is a successful system, introduce systems concepts, and finally, explore the life cycle and innovations of the system itself. Now, let's explore the wristwatch. The history of timekeeping and watches is interconnected. For almost as long as humans have walked the earth, the methods used to measure time have changed dramatically. Countless theories regarding inventions, dates, and even inventors exist, but some significant milestones mark our fascination with recording the passage of time. The mechanical clock was invented in England in 1275. Mechanical watch movements and eventual graduation to a wristwatch followed. A movement is what makes a watch go. Manual and automatic movements are made up of only mechanical parts, like gears and springs. Most collectors and connoisseurs prefer manual or automatic watches, as these movements represent the accumulation of over 600 years of refinement, expertise, and craftsmanship. Today, we are going to explore the wristwatch specifically, as it has revolutionized the timekeeping industry and made human life more convenient. A wristwatch is a successful system because it is an integrated set of elements that accomplishes its defined task of displaying the time of day in a convenient and reliable way. Now, I will introduce the systems thinking concepts of classification, system boundary diagram, systemogram, structure and visibility, spatial arrangement, and evolution. A wristwatch is classified as a physical system existing in the reality of space and time and consists of many elements that interact in a meaningful manner. Furthermore, a mechanical watch is a non-living and man-made physical system. This simply means that it has no genetic connections to continuously renew the same elements and was intentionally created to augment human life. This is a systems boundary diagram of the wristwatch. A wristwatch is an open system that interacts with its environment in a specific way. It has inputs such as winding the watch and outputs such as displaying the time of day. The system's boundary for the wristwatch is the case itself and the strap. Internal feedback like errors can affect the system, while external feedback like reviews and technology advances can drive change in the design of the watch. This is a systemogram. It's a conceptual, graphical model showing the main components and relationships in the wristwatch. This systemogram shows how many elements and advances have gone into the production and advancement of the wristwatch. The structure of the wristwatch is broken up into 4 categories. The metasystem of the timepiece is the industry and watchmakers. The system is the wristwatch itself. The subsystems are the strap and the complex networks of gears and springs that make the wristwatch function. And finally, the elements are the individual clasp, gear, and springs that make up the system. The visibility of this system depends on your perspective. Watchmakers will have a white box perspective, recognizing complete transparency on a system's internal elements and processes. An average user would have a gray box perspective, having only partial knowledge of the processes. Now, I will discuss the evolution of the wristwatch, specifically its movement. A manual movement, frequently called a hand-wound movement, is the oldest type of watch movement made, dating back to the 16th century. It requires daily winding in order to work. Manual movements are the most traditional movements and are usually found in very conservative, expensive, and collectible watches. An automatic, or self-winding, movement is a mechanical movement first marketed in the beginning decades of the 20th century. It winds itself while worn on the wrist, eliminating the need for daily hand winding. However, if not worn for some time, the watch will stop and require manual winding. A quartz movement uses a battery for its power source and does not need winding like a mechanical watch. It is the most accurate type of movement currently being produced. Quartz models have also made way for the opportunity to integrate new technologies like GPS and activity trackers. Now, I will walk you through the system's life cycle of the wristwatch. First, we need to establish the system need by defining the problem and identifying stakeholder needs. Late in the 19th century, European soldiers were outfitted the device with unbreakable glass to survive the trenches and radium to illuminate the display at night. Officers on horseback needed a way to check the time quickly without pulling out a pocket watch while riding. and civilians, seeing the wristwatch's practical benefits over the pocket watch, were parroting the behavior. Pilots and racing enthusiasts were also looking for a small, reliable timepiece. Next, we developed a systems concept by refining system requirements and proposing feasible concepts. The wristwatch needed to be made of durable materials while remaining portable and reliable. The third step in the life cycle is design and develop the system. Pocket watches were adapted for wrist wear by being placed in leather cups with the wrist straps like the one that is shown in the picture. These were called wristlets and had the benefit that a man could wear his watch on his wrist when circumstances demanded and then return it to his pocket when fashion rather than expediency ruled. Next is the production of the system. Arthur Garston established his business as a manufacturer, wholesaler, and retailer of leather goods in 1870. The first wristlets, or wrist straps, for pocket watches were probably one-off affairs, commissioned by officers who, frustrated with repeatedly having to haul out their pocket watch, realized that it was a good idea and got their local saddle maker or some other leather worker to make a custom strap for them. The registration of the wristlet strap design in 1893 shows that by then there was a sufficient demand to make it worthwhile of producing an original design that could be registered and put into production. Next is to deploy the system. Wristwatches started locally and then demand raised very quickly. Manufacturers started deploying early models of the wristwatch to soldiers and the societal elite. The sixth step is to operate the system. The wristwatch's operation drove its evolution. Once people realized the convenience, they started to add more and more features to the watch itself. Pilots and racing enthusiasts demanded chronographs, while societal elite demanded more luxurious and day-to-day features like day and date. Finally, we must refine and retire the system. The wristwatch has support from stakeholders and continues to evolve today. There is no current retirement plan, as the wristwatch is still widely popular and ever improving. Now, I will identify the two main types of risk encountered throughout the life cycle of the wristwatch. The first is technical risk, which is the possibility of system requirement not being achieved. The main requirements were reliability, portability, and durability. Throughout the process, designers and manufacturers played with and improved each aspect. Next is systematic risk, which is loss of system if one element fails. This is the biggest risk for the wristwatch during the operational phase of its life cycle. If one element of the watch is not working properly, then the entire system will fail. Now, I will talk about the stakeholder and their role in the life cycle. Decision authority stakeholders and owners interacted with clients, users, and consumers in order to create different models and features to the watch. This interconnected system enabled every stakeholder to have a seat at the table during the life cycle of the watch. Thank you for watching my video on the systems concepts of the wristwatch, and I hope you learned something.